Welcome back. We're now starting section 1.6, limits involving infinity. Now, in the past, we had this. Recall from section 1.3, when we take the limit as x approaches 0 of 1 over x squared, that actually would be equal to does not exist, because when you plug in 0, 0 squared is 0 and 1 over 0, you can't divide by 0. Now, 1 over 0 is different from the 0 over 0 indeterminate form. A number divided by 0 does not exist. That's what we talked about and made a definition in section 1.3. But in section 1.6, we are going to go back and re-look at this type of problem here. So, to really analyze a limit, we're going to remember what limit means. When we take the limit as x approaches 0 of 1 over x squared, we're going to get very, very close to 0 from both sides, from slightly below 0 and slightly above 0. And plug it into this function, and we're going to try to figure out what number we're approaching. So we're going to take a look at this particular problem from a table method. So here we go. I'm taking the limit as x approaches 0 from the left. From the left, that means slightly below 0 of 1 over x squared. So we're going to plug in numbers very, very close to 0 from the left. I'm going to plug in numbers like negative 0.1, negative 0.01, and negative 0.01. I'm going to get close, closer, and very close. Now, this clearly is going to require some calculator work here. So I'll pull out my calculator, and I'll put it right here. So 1 divided by parentheses, plugging in negative 0.1, and I'm going to square it. Notice the wonderful use of parentheses that I'm doing on this thing here. So let me blow it up. You guys can see this maybe a little bit better here. Now, as I plug it in, 1 divided by negative 0.1 squared. Now, order of operations, we're going to square negative 0.1, which makes it positive. And when I do that, I end up getting a positive 100. Now, I'm going to do 1 divided by parentheses, negative 0.01. And we're going to square it. And that gives me 10,000. And now I'm going to get very close. Now I'm going to plug in for x, negative 0.001. That'll be 1 divided by parentheses, negative 0.001, close parentheses squared, and I end up getting 1,000,000. So, as x approaches 0 from below, what's happening to my numbers? I'm going 100, 10,000, 1,000,000. My numbers are blowing up to infinity, and that's a positive infinity. So we would say the limit as x approaches 0 from below of 1 over x squared goes to positive infinity. Now, if you graph this thing, this is like 1 over here, 0.1 and 0.01, so this is like 100, 1,000, 10,000. So this is what the graph looks like. And as you get very close to 0, here's 0, from below, the thing is blowing up. Now, here we go. Now let's plug in positive 0.1. So I'm going to 0 from the plus side. So here we go. 1 divided by parentheses 0.1 squared. And I end up getting, oh, what a surprise, 100. And now I'm going to 1 divided by 0.01 squared, 10,000. Notice I'm getting the same numbers again. And 1 divided by 0.001 squared, I get 1,000,000. So, as we get very close to 0 on the plus side, you will notice my functional value goes from 100 to 10,000 to 1,000,000. It continues to blow up to positive infinity. So if I graph that, over here is positive 1, this is negative 1. 0.1, I get 100. 10,000, 1,000,000, then my numbers are going up again. So it's very symmetrical here. This is what's going on. But since the limit from the left equals the limit from the right, now granted we're blowing up to infinity. Now this is what's new about 1.6 versus section 1.3 that we did before. Now what's different about 1.6 is we're now going to start allowing having answers of infinity. Since the limit from the left is equal to the limit from the right, we would say that the limit as x approaches 0 of 1 over x squared is actually equal to infinity. And we're going to allow you to have infinity answers. This is that aspect of engineering calculus, scientific calculus that we play with. We can have infinity answers. They're blowing up because my definition of limit is still satisfied. The limit from the left is actually equal to the limit from the right. They are going the same thing. They just happen to be blowing up to infinity. However, let's look at this problem in contrast. Evaluate the limit as x approaches 0 of 1 over x using the table method. Again, same problem. If I plug in 0, first rule of limits, plug in a number. 1 over 0 does not exist. A number divided by 0 doesn't exist. It's only 0 over 0 we get to do that wonderful algebra stuff with that indeterminate form. But this is a number, 1 divided by 0. That does not exist from section 1.3. But I'm going to do the table method again. I'm going to get very close to 0 from below. I'm going to get very close to 0 from above. Now, as we do this, again, I'm using my calculator. This will be 1 divided by, now it's just negative 0.1 in the denominator. And that gives me negative 10. Now I want to plug in negative 0.01 into my x. 1 divided by negative 0.01 gives me negative 100. And last, 1 divided by negative 0.001. That gives me negative 1,000. So as I approach 0 from below, from the negative side here, you'll notice that my numbers are going from 10 to 100, negative 10 to a negative 100 to negative 1,000. It gets bigger and bigger and bigger negatively. It's going towards negative infinity, aka very, very small. But now if I plug in positive numbers, 1 divided by 0.1, that's actually positive 10. And 1 divided by 0.01 is positive 100. And 1 divided by 0.001, that is 10,000. I'm just going to make 1,000. So as x approaches 0 from the plus side, I'm going from 10 to 100 to 1,000. And the next one would have been 10,000, 100,000. It's going up to positive infinity. Now, if we graph this over here, so over here is negative 1 again, but if I go to negative 0.1, I'm getting negative 10, so it's down here, and then go closer to negative 0.01, it's doing negative 100, negative 10,000. My graph looks like this. However, and here's 0, but on the positive side, and here's 1, if I plug in numbers like 0.1, it's positive 10, positive 100, positive 1,000. It looks like this. So right here at 0, because the limit from the left is going to negative infinity and the limit from the right is going to positive infinity, one's going down, one's going up, we would say the limit as x approaches 0 of 1 over x actually does not exist. No solution. And the reason why it's no solution, we're going back and looking at the idea. Well, look at the limit from the left. It's going to negative infinity. The limit from the right is going to positive infinity. It's not going to the same infinity. One's going down, one's going up. Remember our definition of limit, you had to go to the same number. And we're going to start creating infinity and treating him like a number. So if I'm going to, both sides are going to positive infinity, we'll get a positive infinity answer. It happens to be both sides are going to negative infinity, we'll have a negative infinity answer. However, if one side goes to negative infinity, the other side goes to positive infinity, the full limit does not exist. So that basic definition still holds. So, let's take a look at this next example here. All right, now to tie it into what's really going on, and even on this last picture that we just had, you will notice that x equals 0, and both of these examples that we just did are vertical asymptotes. And remember from your pre-calculus college algebra days, to find a vertical asymptote, you got some kind of rational function and you set the denominator equal to 0. That's where we're getting that a number divided by 0 part, which where the denominator equals 0 is where you find vertical asymptotes. So, but from a limit perspective, when you get a vertical asymptote, you can't cross a vertical asymptote. So on one side, it's either going to blow up to positive infinity or possibly blow down to negative infinity. And the other side of A, if x equals A is your vertical asymptote, is either going to blow up to positive infinity or blow down to negative infinity. So let's take, and the only way to figure this stuff out is we're going to have to do chart work. This is where you do chart work. You don't do chart work on all the limit problems. We want you to do that algebra, especially with the 0 over 0 and all the different algebra techniques you can use. But when it comes, when you plug in the number and you get a number divided by 0, that's when you want to do your chart work. So let's take a look at this example here. take the limit as x approaches 2 of 2x plus 1 divided by 3x minus 6 quantity squared. Well, the first rule of limits is plug in a number. So let's plug in a number. Plug in 2. If I plug in 2 here, I'm going to get 2 times 2 plus 1 over 3 times 2 minus 6 squared. 2 times 2 is 4 plus 1 is 5 divided by 3 times 2 is 6 minus 6 is 0. Squared is still 0. It's a number divided by 0. And the rule of thumb is this: when you get a number divided by 0, the answer is either going to be infinity, negative infinity, or does not exist. You got a 33 of 30% chance of guessing at this one, because anytime you got a number divided by 0, it's got to be one of these particular answers: infinity, negative infinity, or does not exist. Which one is it going to be? Well, the only way to figure it out is you got to do your chart work. So we're going to take the limit as x approaches 2 from below of this 2x plus 1 over 3x minus 6 squared, and we're going to create a little chart for that guy. And at the same time, we'll come over here and we're going to do the other side limit. Take the limit as x approaches 2 from the plus side of 2x plus 1 over 3x minus 6 squared. And let's do a little chart work. All right, here's my x and here's my y. What we're going to is we plug it in. Now, I'm trying to go to 2 from slightly below 2, less than 2, because this number line, we're on the left side of 2. Left side of 2, if you look at your number line, will be numbers like 1.9, 1.99. And all you really need is just a couple of numbers to see what's going on. Because remember, if it's a vertical asymptote, which 2 is, because that makes me divide by 0, a number divided by 0 here, 5 divided by 0, it's either going to blow up or blow down. I just got to figure out which one it's going to do. So you got to have at least 2 numbers to plug in. So here we go. Let's use my calculator again. So, parentheses around your numerator. 2 times 1.9 plus 1, close parentheses, divided by parentheses, 3 times 1.9 minus 6, close parentheses, and square for the denominator parentheses, enter. I got 53.333 when I plugged it in. Now I'm going to take the same function and plug in 1.99. 2 times 1.99 plus 1 divided by parentheses 3 times 1.99 minus 6, close parentheses, squared. What did I get? 5,533.333. So as this approaches 2 from below, less than 2, I'm going from 53 to 5,533. The numbers are blowing up. That would be positive infinity. So the answer for this one-sided limit is positive infinity. Now let's do this second guy. Now I'm going to plug in numbers close to 2 but slightly above 2. So here's my x's, here's my y's. So this will be 2.1 and 2.01. Get close and get a little bit closer. This is just telling me what's going on, because I know it's either got to be positive or negative infinity on this stuff. So let's take a look. So let's plug it in. 2 times 2.1 plus 1, close parentheses. Oh, parentheses there. I forgot to start my parentheses in there. There you go. Parentheses 2 times 2.1 plus 1 divided by parentheses 3 times 2.1 minus 6, close parentheses, squared. Parentheses are very important on these calculators, and we're trying to make it look exactly like the problem that I have where I'm plugging in for x 2.1. And I end up getting, this time I got 57.7778. Now I'm going to plug in 2.01. So it'll be parentheses 2 times 2.01 plus 1 divided by parentheses 3 times 2.01 minus 6, close parentheses, squared. And now I got 5,577.7778. So as this x approaches 2 from the positive side, from the plus side of 2, on the right side of 2, I'm going from 57 to 5,577. Again, they're blowing up to positive infinity. So the limit as x approaches 2 from the plus side of 2x plus 1 divided by 3x minus 6 squared is positive infinity. And since the limit from the left equals the limit from the right, therefore we could say that the limit as x approaches 2 of 2x plus 1 over 3x minus 6 squared is actually positive infinity. It was that answer. But the only way to tell is we had to show your work is you have to do the chart work. So let's take a look at this next guy. And this one I broke up into 3 different parts here. Take the limit as x approaches x approaches negative 4 from the plus side of x plus 6 over x plus 4. Now this is a one-sided limit. So I'm going to plug in numbers. Now first off, I should really plug in my number to show you that we get a number divided by 0. So plug in negative 4. First rule of limits is plug in a number. This will be negative 4 plus 6 over negative 4 plus 4, which is 2 divided by 0. What a surprise. Number divided by 0. So when you got a number divided by 0, to actually figure out the limit, we want to do our chart work. This is the only time we do chart work. This is just plain old numbers divided by 0. When you get 0 divided by 0, it's got to be a special case to do the little t-bar stuff, like when we had that trig divided by polynomial stuff. But usually we want to use algebra with 0 over 0, those indeterminate forms. All right, so now I want to go to negative 4 from the plus side. So here's my x, here's my y. Negative 4 from the plus side. Now if we look at a number line, here's negative 4, here's negative 5, here's negative 3. Negative 4 from the plus side is on the right side of negative 4. So what kind of numbers are to the right of negative 4? Well, numbers right in here would be numbers like negative 3.9 and negative 3.99. Notice I drew my number line to figure it out because that's where most students will make their mistake at. So numbers slightly bigger because they're negative numbers, bigger than negative, because remember, negative 4 is smaller than negative 3. Negative 3 is smaller than negative 2. So we're talking about on the negative side here. So to be slightly bigger than negative 4, you want negative numbers like negative 3.9 and negative 3.99. So now I'm going to take my calculator and plug in these numbers in for x. So it'll be parentheses, negative 3.9 plus 6 divided by negative 3.9 plus 4. I end up getting 21. Now I'm going to plug in negative 3.99, parentheses, negative 3.99 plus 6 divided by parentheses, negative 3.99 plus 4. I can get up 201. So as we approach negative 4 on the plus side, I'm going from 21 to 201. My numbers took a big jump, so it must be going towards positive infinity. Remember, when you have a number divided by 0, the answer is either going to be infinity, negative infinity, or does not exist. In this case, this one-sided limit, the answer is positive infinity. So the limit as x approaches negative 4 from the right of x plus 6 over x plus 4 is positive infinity. But now I ask you to do this problem. Take the limit as x approaches negative 4 from the left. Now from the left, now we've already plugged in negative 4 on this thing, and when I did it before I got 2 divided by 0, a number divided by 0. So I'm going to do a t-bar here once again. But this time I'm going to plug in numbers slightly less than negative 4. So this will be going to negative 4 from the left. So as you plug in numbers like negative 4 from the left, I got to be smaller than negative 4. So remember, negative 5 is smaller than negative 4, so I want numbers like negative 4.1 and negative 4.01. So those are the numbers I'm going to plug in. Negative 4.1, negative 4.01. Be x, and let's plug it in and see what we get y is. So here we go. Parentheses, negative 4.1 plus 6 divided by negative 4.1 plus 4. I got negative 19. And now I'm going to plug in parentheses negative 4.01 plus 6 divided by negative 4.01 plus 4. Negative 199. So once again, as my numbers get very close to negative 4 from below, from the right, from the left, from below, my numbers are going from negative 19 to negative 199. They're going towards negative infinity. Therefore, I can state this, that the limit as x approaches negative 4 from the left of x plus 6 over x plus 4 is equal to negative infinity. But now, look at this question here. What is the limit as x approaches -4 of x plus 6 divided by x plus 4? Well, to get a full limit, I didn't notice there's no little plus or minus behind the number here. Do a full limit, you've got to look at the limit from the left and versus the limit from the right. The limit from the right was in positive infinity. The limit from the left was negative infinity. They're not going to the same infinity. Therefore, my answer for the limit as x approaches -4 of x plus 6 over x plus 4 is D, N, E. No solution does not exist. We would accept no solution doesn't exist. D and E's does not exist. Okay? So again, these are just kind of previews of what this chapter is going to be all about. And then there's this last little bit. And this whole idea of limits, dealing with infinity and stuff, we're talking about limits as infinity. So there's something new here. A limit as the domain approaches infinity. The limit as x approaches infinity of f of x. So as x gets really, really big, what's happening to the function? Well, there's a major idea going on right here. And that is this. If you look at a polynomial, which is what we're going to be focusing on with this stuff, if you look at a polynomial that say it has a degree p, okay, then you're going to multiply both the numerator and denominator by 1 over x to the p. The reason for that is this. We have an idea. So let me write my little idea over here. This is an important idea. Okay? And that is this. When I take the limit as x approaches infinity of 1 over x, what does that equal to? Limit as x approaches infinity of 1 over x. Plug in infinity. First rule of limits, plug it in. What's 1 over infinity? Well, 1 over 100 is 100th. 1 over 1,000 is 1,000th. 1 over 1,000,000 is 1,000,000th. What's happening to my numbers? As the denominator gets bigger, the fraction goes to 0. And so the idea that we're talking about here is when I take the limit as x approaches infinity of 1 over x to the positive power. P is a positive power. It's a degree, so P has got to be greater than 1. Okay? Basically, anything greater than 0 would work. Any kind of positive power. That'll be later on. But limit as x approaches infinity of 1 over x to the p, where p is a positive power. As long as the infinity is in the denominator, a fraction goes to 0. It has to be a positive power because if it was a negative power, you would clean up your algebra. Negative exponents, if they're on the denominator, will go back to the numerator, and that messes it all up. So here's the idea right here. We're going to take the limit as x approaches infinity of 6x squared plus 2x plus 7 divided by 8x plus 2x squared. And how we do this particular problem with this idea is, here's my focus. First, identify the degree of the denominator. Look at your polynomial. You have the denominator, the guy on the bottom. I have 8x plus 2x squared. What is the degree? Well, I have an x squared in it, so it's a degree 2. So now, the trick is we're going to multiply both the numerator and the denominator by 1 over x squared. This is showing my work. It's a 1 over x squared divided by 1 over x squared is a ratio of 1. So this doesn't, by multiplying by this guy doesn't change my problem. Okay? Now my next step is I'm supposed to distribute and clean up my algebra. So this is going to end up being the limit as x approaches infinity, and I'm going to distribute. 6x squared times 1 over x squared. X squareds cancel, I got 6. Plus 2x times 1 over x squared is 2 over x. Plus 7 times 1 over x squared is 7 over x squared. Divided by, now I'm going to distribute my denominator. 8x times 1 over x squared is 8 over x. I'm cleaning up. X divided by x squared is x on the bottom. Just cleaning up my algebra as I go. Plus 2x squared times 1 over x squared. The x squareds cancel, and I'm left with 2. The whole purpose of multiplying by 1 over the degree of the denominator, what our focus is here, is using this idea that when I plug in infinity with the x in the denominator, the fraction goes to 0. Now, according to my limit laws, you go after wherever the x's are at. So I'm going to take the limit as x approaches infinity for all these x's. But when I cleaned it up, these are the only terms that have x's in them. And notice that each one of them we turned into little fractions where the x is in the denominator. According to this rule, we don't care what the numerator is. These guys, these little fractions, are all going to go to 0. Leaving me with 6 divided by 2. 6 from the numerator and divided by 2 in the denominator, and you can clean that up. That's equal to 3. My answer is the limit as x approaches infinity of 6x squared plus 2x plus 7 divided by 8x plus 2x squared is actually equal to 3. Take a look at this next guy. Another example. The trick is when you got a polynomial divided by a polynomial and you're either taking the limit as x approaches either positive infinity or negative infinity, it doesn't matter. Take the limit as x approaches infinity. All right, first I got x cubed plus 4x minus 2 over 6 minus 2x squared. First, focus on the degree of the denominator. The degree of the denominator is a 2. So I'm going to once again multiply 1 over x squared in the numerator and 1 over x squared in the denominator. It's a ratio of 1. Now I'm going to distribute both throughout the numerator and the denominator. This is the limit as x approaches infinity. You keep writing limits until the point you plug in the number. So now x cubed times 1 over x squared. Well, x cubed divided by x squared, that's just x. 4x times 1 over x squared gives me plus 4 over x, because x cancels with just one of those x squareds, leaving me with an x left in the denominator. Minus, and 2 times 1 over x squared is 2 over x squared. Divided by 6 times 1 over x squared is 6 over x squared. Minus 2x squared divided by x squared is just 2, because the x squareds cancel there. Classic distributing. Now once again, all the terms that have x in the denominator, according to my idea over here, that when infinity is in the denominator, the fraction goes to 0. But there's a problem, so I keep writing limit, because there's a term left over. There's an x left over. And there's a negative 2 in the denominator left over. So pay attention and follow your nose. So I'm not done with plugging in infinity yet. I only got rid of all my little fractions here, but there's a term left over with this guy. Now, plug in infinity. Infinity, well, it's in the numerator is infinity. But when I divide by negative 2, that's a positive infinity. A positive infinity divided by a negative 2. So what's half of infinity? Well, it's still infinity, but a positive divided by a negative is a negative. So that would be negative infinity. That's my answer. It's infinity divided by negative 2. Infinity on top is going to be infinity. But because it's a positive divided by a negative 2, positive divided by negative is a negative, but the infinity on top remains. And the answer is negative infinity. One more of these guys. Take the limit as x approaches infinity of 2x divided by 2x squared plus x minus 1. Again, because we're doing a limit as x approaches infinity here, I'm going to multiply both the numerator and the denominator by 1 over x to the degree of the denominator. But once again, the degree of the denominator, being polynomials, is a 2. So I'll multiply both the numerator and the denominator by 1 over x squared. Okay, in all my examples, the degree of the denominator happened to be 2, but that doesn't always work. It's just in these examples I made up. Now we're going to clean this up by distributing. This is the limit as x approaches infinity of 2x times 1 over x squared is 2 over x, divided by 2x squared times 1 over x squared, that's just 2, plus x times 1 over x squared cleans up to be 1 over x, minus 1 times 1 over x squared is minus 1 over x squared. Again, with all your little fractions, when as x approaches infinity, or negative infinity, in the denominator, all these terms go to 0. That leaves you with 0 divided by 2, but now, 0 is in the numerator now. What's 0 divided by 2? Half of a 0? That's still 0. The answer is 0. So, this is how you actually do one of these limits to infinity kind of problems. Now, however, there's more to the puzzle on this one. What we're really doing here, since we're taking the limit as x approaches positive infinity, or even negative infinity for that matter, we're finding something called horizontal asymptotes. And your teacher's going to go over what you used to do in pre-calculus, college algebra stuff, with horizontal asymptotes having to deal with the degree of the numerator versus degree of the denominator. There's a pattern to this stuff, so you can actually look at these problems and kind of tell what the answer is even before you start. It's you'll notice here the degree of the numerator is 2, the degree of the denominator is 2. All smaller terms go away, and so you're just left with 6x squared over 2x squared. The x squareds cancel. 6 divided by 2 gave me my 3 answer. When the degree of the top equals degree of the bottom, the answer is going to be the ratio of the leading coefficients. Here, I got x cubed plus 4x minus 2 divided by 6 minus 2x squared. The numerator has a degree bigger than the denominator. When the numerator is bigger than the denominator, you don't have a horizontal asymptote. The answer is going to be either positive or negative infinity in that case. Well, anytime the degree of the numerator is bigger than the degree of the denominator, the answer is plus or minus infinity. The problem is you don't know which one it's going to be until you actually do the work. And the last case here is, you'll notice that the degree of the top, that's 2x officially to the first power, so degree is 1, over 2x squared plus x minus 1. The degree of the top is less than the degree of the bottom. And when the degree of the top is less than the degree of the bottom, the horizontal asymptote is 0. There's something called the horizontal asymptote theorem that we're going to tie in together with this stuff. But what we're interested in is your ability to do limits, in this case to infinity. And there's a lot more to the puzzle on this stuff, so we're going to make these problems a little bit more complicated, but that's what your teacher's going to go over in class. So I hope this has been helpful, and I'll see you on the next video.